Hello there, this is Dizzy, and it's time to play some Minecraft. So last time we built this nifty little cryothium generation system, which allowed us to cool our reactor down quite a bit more. And that in turn let us run the highly enriched uranium fuel. And we also, if you can see over there in the corner, built that battery backup system so that we have a way if, when our reactor runs out of fuel, for us to get things bootstrapped and going again until we can make some more. So, from a functional perspective, we've got a pretty sort of reliable reactor at this point. We do have to periodically feed it a little bit of redstone to make the cryothium, and of course, a fuel of some sort. But one of the things that we're starting to really get a lot of is a bunch of different types of byproducts from when we reprocess the fuel. And we need a little more automated way of dealing with that, in part so I don't irradiate myself, but also so that I can start to understand, how much of the byproducts we have so we can start to burn other kinds of fuel in an easier to reason about way. So we need to do a little bit of automation there. We also need to set up a rock crusher to start gathering materials for the more sort of higher end pieces that we want to build. And I really want to get to a point where I can build a molten salt reactor. But before we can do that, we've got to have a steady supply of some of these other more exotic materials, which you get from crushing up rocks like granite, andesite, and diorite. So that's what we're going to focus on for today. So with that in mind, one footnote from last time is that the way that this electrolyzer and fluid infuser so that we can oxidize our fuel is set up, it will run constantly, because what happens is that the electrolyzer generates hydrogen, deuterium, and oxygen. The oxygen gets pumped into the fluid infuser until it's full, and then it just starts getting shunted into the nullifier. And so what happens is this thing never stops running, and it burns a lot of fuel. So I got a lever, and I'm just going to place it in front of this and turn the thing off. And that way I'll just run it when I need to. It's not perfect, but it'll do the trick. So something to keep in mind, otherwise you'll burn a lot of uranium, which is exactly what I did overnight. And that made me really grateful for this battery backup system we've got set up here. Okay, so rock crusher. What we're going to need is an igneous extruder that can generate the different kinds of rock that we want. I made a rock crusher from NuclearCraft, of course, and I have some signal and plated fluid ducts. So sort of on this side of the workshop, I've got everything plumbed into a sink because that is my water generation of choice, mostly because it's ridiculous. And so this signal and plated fluid duct lets you sort of pump a fluid as well as power up to 4,000 RF per tick through it, which is fine for our purposes. So what I'm going to do is I'm going to move this energetic infuser because it doesn't need to be here. And we're going to pull that out and replace it with our signal and plated fluid duct. And then I'll also hook that right there. So then we'll set up I think what we'll do is we'll put the rock crusher on this side, and then we'll put the igneous extruder on that side. Now, we're going to need some lava. But you can see here that it can generate basalt, cobblestone, of course, and stone, obsidian, but granite, diorite, and andesite are the ones that we're interested in this time. And we're going to leave this, the workshop as a whole, this whole setup and this whole building, it's not about automating everything. It's about automating enough to make it possible to sort of work our way up the chain. I have plans for a factory in the future that will be fully automated for a lot of this stuff, but we're just not there yet. And to do it right, you need a lot of sort of complex mechanisms around back pressure to make sure that you don't overproduce stuff and so forth. So that's not the goal of this building, so it's okay if stuff is a little manual. So we'll start with, I guess, granite. And like normal smooth stone, you need 1 bucket of lava and then an unlimited supply of water, which we have. So let's get some lava. Where can we get some lava from? Actually, there's a thing outside. Maybe we'll just go out there, but we need a bucket. Yeah, we haven't actually left the building in a few episodes, have we? And let's make sure we have a sword, and let's put on our pirate suit here. This might be a bad idea. Is it a bad idea? Oh, there's no creepers yet. I'm just going to get a bucket of lava real quick. We could have made it in the workshop, but we might as well get outside the building a little bit. So yeah, so this is sort of my complex at this point. It's a workshop. What happened to that tree? Huh. My plan is to clear that area across the river and turn that into, I want to make a greenhouse where we do all of our mob farms and farms. And then also we'll spread that way to start building the factory too. But that's a ways off. What happened to my fences? What the heck is going on here? It's actually gone. That is really strange. All right. So we got our lava. Let's go put it into our generator here. Yeah, and I'm actually going to disable this for the time being because we don't want it to start generating just yet. All right, so that's set up. We've got power, we've got lava. We're going to make granite, so let's just go ahead and let this run then. Oh, crap, where's it putting it? Is it putting it in the back? Yeah, all right, great. So then it's feeding directly in the rock crusher, which is great. Let's go ahead and upgrade this a little bit. That should speed stuff up, and it's only 40 RF a tick. And then let's get some upgrades for that rock crusher too, so it'll speed things up there. Upgrades. I think I made a bunch, yeah. All right. So the rock crusher, I don't know that we need 20, so we'll just do 10 of each. And of note, you only ever need as many efficiency or energy upgrades as you do speed upgrades. If you put more energy upgrades in, they won't do anything. They have to be matched the number of speed upgrades. So great. So that is generating things like rhodochrosite. I don't know what that is. Sulfur, crushed williamite. And you can use these things to make different solutions. Some of the stuff you need to make, for instance, radiation scrubbers, which is something that's going to be really important for us. Other things like the rhodochrosite we make other alloys with. And what we're going to do is we're just going to let this run for a while until all these guys are full, and then I'll switch over to a different kind of rock. So while that's running and generating what we need there, let's do the fuel reprocessor. Now that is it should be a pretty simple little project. Basically what we want to do is, let's see, I've got a compactor. We've got a fuel reprocessor over here, which we want to get. And there's nothing in there right now. And I'm going to come clean that up in a minute. So the general idea is that we are now pretty much exclusively burning oxide fuels. Now the problem with oxide fuels is when you run them through the fuel reprocessor, and let's see. So when you run, let's find an oxide. It's not oxidized. Here it is. All right, so here's HEU-235 oxide. It generates the byproducts, but they're all oxidized as well, which means that you've got to somehow convert them before you can use them again. Or you have to have enough to make oxidized form of whatever you want. So what I'm going to do is basically set up a furnace. If you cook an oxidized fuel, it removes the oxidation effect, if you will. So we're going to, every time we get something out of our reactor, we're going to cook it in the furnace, pass it off the fuel reprocessor, and then we're going to use the compactor to convert the tiny clumps into something a little more usable. Because the reality is that, you know, if we come over here and look at this, look at the system, tiny, you can see, you know, 2.3 thousand tiny clumps of uranium-238. This is because we process a lot of uranium. You know, we've got a lot of these little tiny clumps, and you can see we've got some oxides as well, which means that they're separate from the other ones. So what we want to do though is these are never useful, independent of sort of the broader, and outside the packed version. What we're going to do is basically get those out of that system so it's not using up storage space and, you know, not just distracting us. So what we're going to do here, do we have... Okay, we're going to have to run some power. I don't know that I want to put it too close to that. Well, you know what? It probably doesn't matter. It probably doesn't matter. So let's just do this. We'll just make it a line like so. And there should be power. Yeah, there's power right there. So let's go get some more signal flux ducts. Okay. almost time to make more signal and flux ducts. Okay, so what we're going to do, I think what I'm going to do is I'm going to have the compactor at the end, and I'm going to put the furnace at this end, and then we're going to put the reprocessor right there. So what'll happen is that we'll pick up the fuel from the fission controller, drop it in the furnace, it'll deoxidize it, the fuel reprocessor will break it down into byproducts, and the compactor, which is sort of a special purpose mod, is going to take those tiny clumps and turn them into, I don't know, whatever the larger unit is. So that's a 3x3 recipe, and we also don't want any recursive compacting. And then from there, what we'll do is we will tie that back into our refined storage system, which, let's see, it doesn't look like we have a cable run over here yet. So we also got to run a cable from somewhere over here. Let's see here. There's a line right there. Yeah, that's fine. We can just extend it. All right, so, and now we've dug ourselves into a hole. All right, let's get some more cables. And then that way it'll automatically import into our system once it gets reprocessed and packaged up. So this compactor will act as a buffer, basically. So this is, I want an importer. All right, so I'll put an importer on the back of that. I will run a cable down here. There we go. And let's just fill in this stuff again. And then that way we won't clutter up our refined storage system with all this other sort of extraneous clumps and so forth, because we really only need the final product. It doesn't really matter. Everything else doesn't matter. Someday I need to figure out how to do camouflage blocks for those. All right. So this guy is going to output to the side and no other. And let's also upgrade him so that he runs a little faster. The fuel reprocessor will give some of those. And then the fuel reprocessor can't actually output to the side, so we've got to do a pipe there. And we need a servo, which of course I don't have on me. Did I make one? I did. Yay, me. All right, so we'll set this up here. All right, so that'll pump into the compactor. The compactor will take the clumps, package them up, and then the importer that we just dropped in will pull them out. And that's all we need for a basic reprocessing system. Now that doesn't sort of do the automatic assembly of the fuels, which is totally fine. We don't, really need that at the moment. Let's go put my radiation suit on because we're going to start handling some fuel. And let's give this a try. So we've got our oxidized HEU 235s. Let's go ahead and plunk it in here. And I'm also going to just turn off importing for a minute so that we can see the byproducts in the packaging. You see it's running a lot faster now. And then you can see over here that this is turning it into sort of complete isotopes from the packaging. And there's a buffer in here, so I think there will be enough room for all the different types of fuels. But like I said, given that this is the workshop, we can always come back later and sort of... in the factory area, we'll automate all of this. And what we might wind up doing is turn it into fluid. I don't know. I haven't quite figured out the best way to do that yet. But the compactor helps a lot. So you can see we've already gotten through all those fuels. It's a lot faster. And by default, they would have already been imported into our system. And you can see that they're already deoxidized as well, which means conceptually we're going to have to reoxidize them. But that, again, it's just a little easier to work with. And probably the right thing to do in the future is to automate sort of the oxidation and the injection into the reactor so that, coming in and going out of the reactor, we just automatically oxidize and deoxidize it. I don't know if that's the right thing to do from a NuclearCraft perspective, but it should work. Let's check on our rock crusher now. Great. So we've got all of these. We've got probably a lot more. Yeah. So let's switch over to this. I'm just going to put this granite on the side, and I'm going to pull that granite on the side, and then we're just going to pull these out. And now we can get these different byproducts of diorite. Now, the other part of this is that fluorite, like you use that, I think, in the melter. Is that? Yeah, so you can make fluorite crystals. You can also mix it with water in the fluid enricher and get fluorite water, which you then make, I think, sodium. You mix it with sodium somehow, and you get, yeah, you can make all sorts of different solutions, which again is stuff we want to get to in order to do things like molten salt reactor. So this is going to be our source. So probably what we eventually want to do is have an igneous extruder for each type of rock going perpetually into a rock crusher and generating as much as we need. But for now, we're going to let that run. And this is also, I think, let's see here, I think andesite is how you get beryllium. And that's actually something I would like to play with if we have time in this episode. Is that right? Is that how you get beryllium? Which you need as a moderator. Yes, andesite gives you beryllium. So let's do this. I'm going to let this run a little bit until we've processed all this diorite and get some beryllium. And I want to make some moderators because I want to see, we're doing pretty good in terms of RF per tick. I actually had to upgrade the energy cell, the signalum, so that it could accept more than 9,000 RF a tick. But our fuel efficiency is 233%, and I'm kind of wondering, you know, we've got a little bit of room, actually a lot of room on our heat per tick. If we put some moderators in there, if we could get better efficiency overall. And that's going to mean our fuel we get more out of our fuel, more bang for the buck. So let me go ahead and cut while this generates. And then once we have enough beryllium to make some moderator blocks, which we're already getting plenty here. And do we have to cook this? Yeah, I think we do. Yeah, we have to cook it. Once we have enough of that to make some moderators, we're going to put those in the reactor and see what we can do. So two little projects. One is our fuel enricher, which is great. Actually, let me turn this on so it imports stuff. And that should pull everything out. Great. And then I'm going to need, and then we'll generate some beryllium, see if we can improve the efficiency of our reactor. And then I'm going to have to do some cleanup because, you know, all these different tiny clumps of stuff, these need to be deoxide, and then they need to be packaged up with everything else. So I think I'm just going to do that manually by slapping a exporter from the network into the oxidation and then do some funny routing or whatever to make that happen. But I will be back in a few minutes once we have enough beryllium to do some interesting stuff. Be right back. Okay, I am back. I've got 10 beryllium blocks, and we're ready to try and increase our efficiency of this reactor. Up until this point, we've just focused on sort of cooling and running higher fuels, but there's also ways to make the fuel burn longer and get more bang for your buck. Right now, we have about 4,000 heat per tick in excess of what we need. We are at an efficiency of 233%. I'm not quite sure where that efficiency comes from other than having the reactor cells next to each other. So I think that, but what we want to do is try this beryllium and see if we can use moderators. Now, the beryllium description says that it's only considered active if it's touching at least one reactor cell. Okay, so we have to keep that in mind. It increases a reactor's efficiency, but also produces some extra heat. And then there's a formula, and it says if there's no adjacent cell, it will instead produce additional heat equal to the base heat of the fuel. So I don't know why you would want to put it in there not adjacent to a cell, because then it wouldn't be active. So let's go ahead and turn our reactor off. So let's remember these numbers. 9408, let me just write them down in a notepad real quick. 9048 RF per tick, 23.3% efficiency, and negative 464. Negative 464 heat per tick. All right, so that's what we're starting from. It's always good to write this stuff down because it's hard to keep track of it once you get into it. So given our current reactor setup, we have a couple of options. One, we can just throw them in next to the cells. So let's just start there. And I think those are reactor cells, so we can put it right between those two. So we're just going to start there. And let's see what that does. We placed 3, look like. Okay. That's pretty impressive, actually. So that gave us another 3,000 or so, just shy of 3,000 RF per tick. Our heat's is still negative, so that's fine. Our efficiency's gone up to 302%. So that's about a 30% increase in efficiency, something like that. Probably 25%. I don't know. Math's hard to do in your head. So very interesting. Just plunking those in there, we get more RF per tick. Our efficiency goes up. I guess the question is, let's see here. Yeah, so the question is, let's take them back out for a second. Because I want to see, in theory, if our efficiency goes up, our runtime should also go up, right? So like right now, we have 5 minutes of fuel remaining at 9,000 RF per tick. And we have the same amount of fuel remaining. So let's see here. Let's put them back in now. So remember that 5 minutes remaining at 9,000 RF per tick. So we put 1, 2, 3, 4 beryllium in. And now we've got 5 minutes at 12,000 RF per tick. So if we do the math on that, so let's see, 12,000, what was the number again? 12,208. So 12,208 times, that's RF per tick, times 20 ticks per second, times 60 seconds per minute, times 5 minutes, is going to be, 7 million. Let's format this as a number so I can actually read it. 73 million RF versus 9,408 times 20 ticks per second times 60 seconds is going to be, let's see here, equals, sorry, I'm doing this in a spreadsheet, so it's kind of a pain. Looks like it's going to be 56 million if I'm reading that number right. Yeah, so 73 million RF remaining versus 56 million. So yeah, that makes a huge difference. Let's see, so that's, if we calculate the percentage, so that's about 29%. So we got 29% more efficient with our fuel. So our fuel will last longer and it burns more just by putting a few beryllium blocks in there. I have to say I'm quite surprised and impressed by that. And we're still heat negative with the cryothium, of course. But that's definitely something worth considering there. I'm sure there's more scientific ways of doing this, but I'm just going to take that simple win. I don't know if, let me just see if I have any more room in here. Let's see behind any of these blocks. I think, yeah, so those are all redstone. There's a cooler up there. And I think it's the same. Yeah, so we don't really have any more room. Now, we could, I suppose, get rid of those 2 redstone. Go ahead and just sort of fill as much as we can up here. And then put all the pieces back. Let's just see what happens if we do that. Then we're heat positive. We got another probably 500 RF a tick. Our efficiency, though, has gone up to 319%, but we are heat positive. And let's see, each of these are 90 RF a tick. Probably not worth it right now. I don't really need that 500 RF per tick at this point. So I'm just going to put those redstones. Where did I have them? Well, they just have to be touching. So let's put one over there. So it says 160, so I think just 2 should do the trick. And then that should put us back to where we were. 24, 30. Oh, interesting. That actually, placing them slightly differently actually had a positive effect. So, okay. but still, we're 308%. So again, we're getting an additional 19 million. Let's see what's the difference here. Equals this minus that. We're getting an additional 16.8 million RF out of the same amount of fuel in exchange for a couple of beryllium blocks placed just so that they're next to a cell. That's pretty impressive. I'm sure there's a more scientific way of doing it that would yield even better results, but I'm going to take it because we get a lot more RF in the grand scheme of things. So that was quite an episode. I did not expect for things to get that good that quickly. So there you have it. Make sure you try out the moderators and put some of them in. They're pretty simple. They don't have to. It doesn't seem like they're too picky. You can just sort of place them so they're next to reactor cells, and you can get quite a bit more RF per tick, and your fuel will last even longer. So make sure you give it a whirl. I think that about wraps it up, though. We had some good sort of small projects, and we'll leave it at that for now. And then we'll see what we get into next time. But have fun as you sort of explore NuclearCraft, and good luck in your reactor designs. Bye.